house on that, and her words of description were peppered with some very colorful language. Because think about a long room with a vaulted ceiling that you could put tall things in and put lights on both sides of the ceiling that are incandescent and very, very hot. That's a paint drying tunnel, you know, where you put in big things and dry it real quick. But no, this was somebody's house. So to think about situations like that, they probably ran into these 100,000 volt amp for that situation. One of the things, if you ever get involved with that, Extreme Makeover comes into town first and says, listen, we're going to do something for TV. And we want a couple things. First of all, you sign off, we'll follow a code, but you sign off of it and fast track it. And you don't raise their property taxes based on what we do in the house. Because we're not going to box them into a corner with long-term bills because we fix something up. And so the city signs off on it, or doesn't. You know, they don't ever tell you how many homes they don't do. Because the city goes, or the county, or whatever, says, nah, screw it, get out of here. You know, everybody likes the publicity, or so to speak. But anyway, that's the kind of situation you run into when you really have a lot of specialty things that only happen very often. That falls into place for things like air conditioning. Think about the people who build a nice fancy house and say, well, twice a year I have a big party and I want to make sure I can cool the place down. Code specifically says you cannot design the air conditioning system for a house in the country, I believe. I think that's an international code, for a special use. You have to design it for a long-term use. So if you have a party and cram a bunch of people in there, what do? Turn the AC on, open all the doors and windows, and turn fans on. Run the bill up like crazy for a couple hours, and who cares? But to close it all down on a hot day and then cram 150 people in there, yeah, it's probably not going to meet it. For a residence, doesn't say anything about a hotel meeting room or anything. It isn't designed for that. So you have to watch all these crazy little options on a house, because think about it. Would I want to design a house for a one-time use or for everyday use? Every day, because what happens if I design the air conditioning system for that one-time use? It's oversized. What does oversized air conditioning systems do when they operate when they're undersized?
Waste power.
Waste power, but how?
They're running inefficiently.
They're running inefficiently, but the real insidious, real thing that bothers me is that it'll short cycle. A big, huge air conditioner in a room with no load will bring it down real quick and then shut off. It's not removed any humidity. It needs that air in the room to pass that coil a bunch of times to wring the humidity out of it. So short cycling makes it cold but doesn't pull the humidity out. So you get cold and clammy, which is a great way to grow mold in your houses. Happens all the time in public schools. How many of you went to public school in Florida? And how many had a school that smelled funny? And it wasn't just because you were all growing up and most of the guys never took enough showers. But no, right? You had very poor humidity control in there because you didn't look at actually what was going on. So we go through here, we've got this lighting little table we do, and then we end up with example 6.4. Let's see, what was it? A two-story, now watch this, two-story house with full basement. And the dimensions were 7.3 meters by 9.1 meters. Okay, now how much, okay, watch this one because we're in Florida. A two-story house with a full basement. Now how do I figure out the total area of this house?
Multiplied by 3.
Multiplied by 3. Okay, what if it said it was a half basement?
3 or 2.5.
2.5, right. Make sure a basement is an additional area. They don't count in the square footage of the house usually. So if they say you got a 2,000 square foot house with basement, usually the 2,000 is the first floor or the second floor, but not the basement. Usually, because they don't count in the living area, unless it's been fully decked out as a residential space. Most basements aren't. So you got to be very careful on real estate ads. When there's a basement involved, what's my real square footage? Make sure you check that. They'll lie to you every time. Well, they won't lie to you. They'll just tell their positive version of the truth. Right. So anyway, 7.3 meters by 9.1 meters, so I can go to that very quickly and go 7.3 meters times 9.1 meters times 3 equals, whoops, not times 3, times 32 volt amps per meter squared. So I got the area times the stories times 32, and I end up with the grand total of 6,377 volt amps. Okay, so that's just for lighting. Right. Now, what about required circuits? I've got 4 required circuits, and those required circuits, if you read the text in there for required circuit, you look at that demand load as 1,500 volt amps per circuit. So in this house, I have a laundry room, 2 in the kitchen, 1 in the bathroom, so I have 4 of those, so I have 6,000 volt amps on required circuits, so I end up with 12,377 volt amps for this top category. Now, we have this table that governs how we load that up to figure out the size of the service just for this category, just for that category. And it says my first 3,000 is 100%. Okay, so let's see. So first 3,000, so 3,000 volt amps, 100%. I've got that. And then I end up with 12,377 volt amps minus 3,000 volt amps times that factor right there, 0.35, or 35%, and that gives me 3,282 volt amps. So if I add up this category here, I have 6,282 volt amps for this category, according to how I calculated the area basis of 32 volt amps per square meter or 3 volt amps per square foot, depending on the units given. I figured that out, put it all together, then used this table right here to figure out the size of the service it would take for just that category. So, part 1. Electric range, we already talked about how we sized that. 8.75 kW, anything below 8.75 kW is 80%, and then it had 0.4 kW for everything above 8 kW, something like that. It had a little table for ranges, so you can figure out the demand for a range. How about when you've got a heat pump or an air conditioning or a furnace system? How do you figure out the load service for those items? Key issue. One's a heater, one's a cooler. Don't add them. Use the largest of the 3. So if I have a house with an air conditioner and a furnace, the electrical service for the air conditioner covers that mechanical compressor and the fan and everything. Electrical service for the furnace only needs to cover the fan. So you make sure you pick the larger of the 2 because they're never going to operate at the same time. You're not going to have your furnace on the same time your air conditioner. You could, but that would represent a failure. Yeah, of some sort. You'd be paying some money to somebody to figure that one out. How come, unless you're in this building, in which case both of them do operate at the same time, and that's another story of long and sad intent. But anyway, when in doubt, pick the larger of the 2, especially when it comes to environmental control, because they won't be, the heating and air conditioning was done on a low budget at the very tail end of the era of pneumatic controls. That's why you go in that back hallway where the conference room is, and you hear an air compressor come on every once in a while. It's a little air compressor running the valves and stuff in it, you know. Yeah. We have distributed digital control, DDC is the name of the game nowadays, but this was probably one of the last buildings built old school. And it shows. They finished it right before a semester. We wanted to get in before the semester started because we were in trailers. You want to get in your building, right? And so we said, yeah, you're done, okay, everything's good. Watch out, another living story. When you accept a building, contractor builds the building and you say it's good, and you take the keys from them, you just bought it. So if it wasn't right, well, you said it was right, you said it was okay, you moved in, how can you come back and say it's not right? They had mixed up the controls in the heating and air conditioning in here, and they had the old line pneumatic control experts come back in and work around some of the newer half digital, half pneumatic stuff, and worked around supposed failures until nobody knew what was going on. 10 years go by and somebody finally figured out the original controls were wired up backwards. So again, when you buy a building, make sure it actually meets your contract. Again, they're going to give you the lowest price per your specification. So you ask to build a barn building, a new food processing facility, a new grocery store, a new house, again, to your specification. So make sure your specification is good. So I've got through my lighting, I've got my range, my stove that I figured out the last time we had an example on that. Air conditioning, I picked the larger of the two. Okay, now, when I go through appliances, I'm going to have to erase something here. You have to be careful on how you do certain appliances. Because of how they operate. Think about an air compressor that's hardwired into a building. Like the one in the shop. You've been through construction class? The air compressor comes on and startles everybody in the back row. Oh my God, what was that? Right? It comes on automatically. So I can't direct when that electrical load comes on. It comes on automatically. What else comes on automatically at your house, electrically? Refrigerator. And with that in mind, so does your air conditioner. So does your water heater. All these things come on automatically. What large electric load does not come on automatically, you control it. Right. Bingo! First got a thermostat. It just says whenever it needs it. Yeah, you can control it, but thermostat, so it can come on anytime. But electric dryer, absolutely. So what we call these other fixed in place can come on anytime you're not in control of it, so to speak, are dishwashers. And think about that. Well, they have different loads all the way through the cycle, but it's just doing that little pump that's barely anything. When the dryer part comes on, it really kicks up the load. So, and there, once you put the thing on, that will cycle, so you have no control over it. So that's a fixed use. A dishwasher is. The water heater is. Sump pump, again, whenever the water comes up, it comes on. So you're not in control of that. And your water pump. Do you have the bladder tank in there?